Hi class, welcome to lesson 19. We are continuing the microeconomics coursework. So for those of you students who are continuing our class, the way it's worked, and I've always explained this, is that first we do microecon and then we'll move on to macroecon. So for those of you dying to get to macroeconomics, I'll get you there soon, okay? But let's try to make sure we cover microeconomics. So in the last class, lesson 18, we went over a couple different things. We talked about costs in the short run for a firm. Specifically, we gave you a lot of terms. For instance, we said, what is MC? What does that stand for? Marginal cost. There's ATC, which is average total cost, AVC, average variable cost, so on and so forth. And we try to define those and try to explain graphically what those mean. Also, mathematically, using a table, try to explain to you guys what really that translates to as a student, how you want to crack problems using different theoretical concepts, but using it in a practical application. That being said, traditionally we do this every time, and today's no exception. We're going to go over the homework answer from the last one. I believe I asked you guys about 4 different terms. First one was marginal cost, right? So marginal cost, for those of you who remember MC, right, is basically the change in total cost, delta TC, over the change in quantity, delta Q, right? And this basically asks the question, what happens when I increase 1 unit, right? So if I'm a producer and I'm increasing my units by 1, how's that going to change my total cost? How much is that? What's the difference? And MC answers just that, or marginal cost answers just that. The next one we went over was a term I asked about was AVC, average variable cost. Average analysis is quite simple, but still powerful, right? AVC basically states that it's the TVC, total variable cost, right, divided by the quantity, okay? That's AVC. The other concept I asked about was AFC. AFC is the same exact thing as AVC, except it talks about fixed cost, right? So it's average fixed cost is equal to total fixed cost over quantity. And lastly, average total cost is basically your total cost. I can write that down. ATC, which is average total cost, right, is equivalent to total cost divided by quantity, okay? And these are the 4 terms we talked about. AVC, AFC is the same thing as AVC, except it talks about fixed costs. And then average total cost is basically total cost over quantity. And then in my opinion, marginal cost, the most important thing for any producer, right, talks about the change in total cost over the change in quantity. That being said, we also graphed these last class. For those of you who are interested in the graph part of it, I can go over it real fast. So that you guys have a general idea of what it looks like. We did go over it last class in detail, but just to recap real quick, I want to go over it in a pretty quick manner. So, we had a graph sort of like this, right? And always remember to always think about, okay, what's my y-axis and x-axis? Whenever you draw a graph in economics, when the grader looks at your test, he's thinking, okay, does this person have a solid idea of what is the x and y axis? Generally speaking, microeconomics, it's a good bet that this is probably quantity or output, right? And this one is some sort of price, or in this case, it's a cost. So I'll put it as a dollar sign over here, okay? So the way we'll start off with average fixed cost. We said that average fixed cost, right, which I can, remember the formula for average fixed cost was total fixed cost, TFC, divided by the quantity, right? That's average fixed cost. So average fixed cost, as you increase the quantity, as Q reaches infinity, right, this whole term kind of reaches 0. And that's the reason why AFC kind of looks like this, right? It kind of falls off. Because as it approaches infinity, quantity approaches infinity, AFC really becomes negligible. And that's why AFC kind of looks like that. And so that is AFC, right? Now, the other one I talked about was AVC, and AVC does not work like AFC because variable cost actually increases as you move on to infinity, and it actually increases exponentially. First, it kind of falls off, but after that, it kind of increases by a lot. So for that reason, AVC sort of looks like, let me make sure I get this right as well. Yeah, AVC sort of looks like that, right? Now, so then we write that down. This is AVC, right? The reason why AVC takes off exponentially as it approaches infinity, as quantity approaches infinity, is because, you know, as you produce more and more, your marginal cost is increasing, okay? And that brings me to marginal cost. And marginal cost is kind of like your Nike swoosh, right? It's kind of like your check mark, pretty straightforward and standard. And I promise you guys, you'll see that you know, Nike swoosh in a lot of different places. But MC kind of does look like a check. Sort of looks like this. And here's the thing, right? Here's the thing, and let me make sure that I get this right correct, because the thing is, MC, marginal cost, right, intersects AVC and ATC at its minimum point. Okay, so make sure graphically you're sort of showing, you're showing that. Well, I couldn't say showing for a while, but basically, you know, the point is that since MC intersects AVC at its minimum point, make sure that the grader can see that. Okay, make sure the grader can see. Okay, so this is the minimum point, whatever it is. You know, make sure it looks more prettier than mine on the real test. But the point is that it intersects in the minimum point, right? Same with ATC. Now ATC, obviously, for you know, when you have total cost, right? Total cost, it has two components, right? It has fixed cost and it has variable cost, right? So your ATC is going to be on top of AVC, right? Because it includes both variable cost and fixed cost. So it kind of comes in here, right? But the thing about ATC you have to understand is, again, intersects MC at its minimum point right over here. But as Q goes on to infinity, right, ATC sort of looks more and more like AVC, because as I said before, so this is actually AVC and this is actually ATC, right? The top is ATC, the bottom is AVC. The reason why ATC kind of looks like AVC as Q approaches infinity here on this side is because the same reason AFC was negligible, right? As Q reaches infinity, we said that if AFC is negligible, what really matters is AVC, right? For your total cost. So that's why ATC and AVC really look similar as Q approaches infinity. Okay, the major points to remember: MC sort of takes off exponentially as Q approaches infinity. MC intersects AVC and ATC at its minimum points. Remember that, very important point. Okay, that being said, that's the recap. Don't want to spend too much time on it because we went over it in the last class. Okay, so I'll erase that after we talk about the next concept. The next one we really want to discuss today would be long-run costs, okay? Because we discussed about short-run costs in the last class, and long-run costs are also important because, you know, if you're a producer, obviously you care about the short run, like how am I doing this week? You know, how is my newspaper, you know, publishing company doing this week, or, you know, in a month. But what's more important is also how am I doing in a year or 2 years or 5 years or 10 years, because, you know, you want to think about long-term growth and, you know, how you've done in the past years and how you can improve it, right? So long run really questions, it's not about, well, what's my daily production and things like that. It's more about scale, okay? So long run really thinks about scale. Am I producing at the right scale? Do I need a bigger factory or capital rather, right? Do I need more equipment, right? So these are the things that, remember, in long run, all inputs are variable, okay? Short run, we've got at least one fixed input, okay? So that's the biggest difference, short run and long run. Before I jump on to long run, I just want to cover one important concept, and that's the relationship between marginal cost and marginal product of labor. The way I'm going to do this is using simple algebra. The reason why we're going over this today is just to make sure that you understand that both MC and MP, marginal cost and marginal product, are actually connected to each other. Productivity is a function of cost. It really does depend. So that being said, let me walk you guys real quick through an algebraic relationship that demonstrates the connection between MC and MP, or marginal cost and marginal productivity. So that being said, so original formula we said was MC is equal to delta, right? Delta TC over delta Q, right? Now remember, in a firm, right, we talked about the fact that fixed costs don't really change. So when we say delta TC, or the change in total costs, the only thing that really changes is what? Total variable costs, right? So that's the reason why MC can also be written as delta TVC over delta Q. Okay? Same exact thing, because the only thing that changes in total cost is actually the variable cost, because fixed costs by definition don't change. Okay? The next thing we do is that we show the fact that the change in TVC, right, is equivalent to the wage, okay, times the change in labor. Okay? Now, why is that? Why does that formula work? Because when you talk about costs, okay, typically speaking, right, and this is the short run, remember, we're still in the short run, so capital is fixed. Your costs are typically labor, okay? It's typically your people that you're working at your company, because things like equipment, factory, and things like that are normally fixed, right? So those don't change. So the variable costs are really the labor costs, and that's why you take the wage, right, which is kind of like a price, because the wage is the amount you're paying to the people that are working at your factory or whatever your place is, times the number of people that are working at your place. Now, since we're talking about the change, you have to talk about the change in labor, okay? So that's why that formula works out to be W times delta L, right? And then what you do is that you take this same thing, you say, okay, it's divided by Q, right? Now, the way you work that formula to your advantage is that the way you manipulate it is that you say that W, right? This is a simple algebra, guys, okay? It's just the fact that this is also equivalent to W. Same thing as saying it's delta Q over delta L. The reason being is that when you divide something, right, you have to multiply that by the inverse, right? So that's why when this and this are the same exact thing. Well, it works out for us that delta Q over delta L, right, or the change in quantity over the change in labor, right, and I'm going to make sure I'm getting this right every step of the way so that I'm not making any mistakes, is the fact that delta Q over delta L is actually marginal product, okay, MP, right? And so this is W over MP. So what this basically says, I'm going to bring it over here so everyone can see it, okay? So MC, right, is equal to W over MP. So it's actually an inverse relationship between cost and productivity, right? Basically based on the wage, okay? This basically says that marginal cost and marginal productivity are actually related, right, through this variable W, okay? So the only point of this exercise, okay, and like, does it really matter if you memorize this formula or not? Probably not. The point is that you guys understand that cost and productivity are actually related to each other, right? And we can use this and prove it algebraically, okay? That's the major point behind this. The two other things I want to cover before I hit long-run costs are just graphs of two things: your average product of labor and your marginal product of labor, and then your marginal cost and your average variable cost. Okay, so those two things, if I just do it graphically real quick, spend a couple minutes on it, we can go over to long-run costs. Okay, so all right, so let's start graphing average product of labor and how that looks like. Now, are these graphs pretty important to understand? I would say so. I think more than anything, if someone asks you on a question, things like that, I think if you have a graphic understanding, and for those of you people who want visual understanding, I think it just works a little better for you guys. So I'm just going to work through algebra as well as graphs. So let's start off with the first graph, right? The first graph basically is graphing Apl and Mpl. Okay, so Mpl kind of looks like this, marginal productivity of labor, and kind of looks like it starts off, the slope is really steep at first and then starts to fall off. Okay, so that's your Mpl, okay, marginal product of labor. And your Apl is kind of like the same story as you've seen previously with average cost. And the way it works is that its maximum, right, is where it crosses Mpl. Okay, so it kind of works like that. That's Apl. So your average product of labor intersects Mpl at its max. All right. So, again, what are the X and Y axis. This is labor, and this is output, okay? All right. Now, the major point of this is to just understand how marginal product labor and APL actually look graphically. You have to understand that your MPL kind of skyrockets at first and then starts to fall off. Now, why is that? It's because of the fact that initially, right, imagine this example. So we talked about pizza before. We said we have a restaurant. I hired one worker, right? And this guy's doing the whole thing, right? He's making the dough, putting the ingredients on, tossing it through the oven, and making that pizza, right? I added a second worker, right? A little better, because all of a sudden they can specialize, right? That word again, specialization, right? And they split the tasks up, right? So one person handles the dough, one person adds the ingredients, right? So they split up the tasks and they're more efficient that way. Third worker, even better, right? So, you know, fourth worker, it's probably its peak, right? But after that, we said the restaurant starts to get crammed, and all of a sudden people are, you know, hitting into each other. Things are getting, you know, dropped, whatnot. So productivity falls, right, after a certain point. And that's basically one of the major reasons why your MPL graph kind of looks like that. So keep in mind your marginal productivity kind of, you know, it kind of skyrockets first, then starts to decline as you increase the amount of labor, right? The one other thing to keep in mind is technology. You know, machines and equipment is a little different, but labor, obviously, we talked about the fact that in short run, capital is fixed, labor is what is variable, okay? So that being said, I'm going to move over here and give you guys a second graph. And the second graph basically covers marginal cost and average variable cost, okay? So another graph, similarly, okay? And I told you guys before, MC is always kind of like this check mark, right? Kind of looks like that, right? That's your MC, marginal cost. Your average variable cost, kind of like a parabola, right? Kind of looks like this. And same thing, right? Same rule that I talked about before. AVC, right, intersects MC at its minimum point, okay? Make sure this is extremely clear to people, right? Especially when they're grading and whatnot. Let's see if I'm missing anything. The output is the x-axis, and price P is the y-axis here, okay? So these are the, you know, I think these are probably the last part of short run costs. And now we shall move on to long run costs. Okay, so what are long run costs? We've talked about this before. We said long run costs are important because you're always thinking at what scale am I operating, right? So if you think about short run costs, right? So at this pizza restaurant, every month, you know, I get a report, right? Because I own this restaurant in my example, right? And I get these reports from whoever, you know, maybe I'm making it up, right? I'm looking at it, and every month I get my expenses, you know, what are my costs, what's my revenue and whatnot, right? But at the end of the year, right, I get this whole entire report looking at all the numbers in, you know, in a big snapshot, right? And I'm thinking, okay, well, you know, these are my costs. Is it worth it to get a second oven, right? To say, okay, can I speed up the process? Can I be more efficient, right? Can I decrease the costs and increase my productivity, right? These are the sort of questions that long run average costs kind of answer, right? So that being said, let me draw first short run average cost together. I'll show you how that becomes into a long run growth. So let me sort of play around with this graph here. I'm gonna erase this. Okay, we'll keep that for now, right? So short run costs kind of over, you know, time sort of look like this, right? So you have your price over here, similar to that one over there, right? You have your price, right, over here on the y-axis, right? On the x-axis, you have quantity or output, same thing, okay? And your short run average costs sort of look like this, right? It's kind of like this average variable cost that I have on my right side, but it's kind of put together, and it kind of works like this. And I'll tell you why the shape of it, you know, works in that manner, right? So this will be short run average cost 1. So these are all your short run average cost, okay? SRAC, okay? Now, the reason actually they take into effect in a parabola is for a different concept, and the concept for long run average cost and the shape of that long run average cost is this concept called economies of scale. Okay? Economies of scale. Okay? And we'll talk about economies of scale and we'll try to define it as such. But, you know, these put together, right, form a long run average cost snapshot that we can look at it from, you know, from the past year. So me as a pizza owner, restaurant, pizza restaurant owner, excuse me, I get to look at the whole thing as a one snapshot, right? So if you just merge these graphs together, your LRAC kind of looks like that, right? It kind of looks like again, a parabola, sort of like a large ABC, right? So it kind of looks something like this, okay? Okay, kind of looks something like that. Now, this is all of a sudden, because of this giant parabola here, this is my LRAC. Okay, long run average cost. The axes stay the same. It's still price, and this is still quantity. Okay, so there are three distinct regions for the long run average cost. Okay, so let me divide it up. This flat area here, where the parabola sort of flattens out, okay, this is called an area, this is called constant returns to scale. Constant returns to scale. And I apologize if you guys are tilting your head, but I'm going to say it again. It's constant returns to scale. Okay? This area here, right? This area here, right? I'm going to move over here and write it down here. Actually, I don't need to because this is actually called economies of scale. Okay? This region is called economies of scale. All right, this region is the exact opposite of the economies of scale, and someone took a lot of time to think about this, and this is actually called diseconomies of scale. Okay? So it's called diseconomies of scale. And I'll tell you each region and why it's called that thing, okay? So let's start off with economies of scale. What is economies of scale? All right, so when you look at a long run average cost, okay, what tends to happen for a producer is as he continues, right? So imagine me, okay, I'm this pizza restaurant owner, right? Just started my shop, okay? It's been a year. I've done moderately well, but I'm still a small player, okay? And with my profits, I decide, you know what? I want to grow, okay? People generally, business, right? Remember that goal we talked about. Every firm, right, it's an organization, right, that produces some sort of good and service, right, using factors of production, right, land, labor, and capital. And the goal is profitability, right? So every firm is thinking, okay, how do I increase my profitability? So this, pizza owner, right, this pizza restaurant owner is thinking, how is he going to grow his restaurant, right? Whether that be more branches, bigger place, whatever it is, the point is, right, they want to take advantage of this, right? This is called economies of scale. Economies of scale basically is the advantages that occur, okay? I can write this down for you guys. Let me start to define this. I'm going to go ahead and erase this part, and I'm going to, actually, you know what, I'll use that side of the board. And basically, I'll define economies of scale here, right? So economies of scale are the following, right? Economies of scale are advantages that occur for a producer in the long run. Okay? Okay, so why do these happen? Okay? Why do these advantages take place? Okay? There's two main reasons, okay? One is specialization, right? and we'll talk about this. We have talked about this, but I'll talk about it again. Specialization. 2 is ability to purchase. Ability to purchase efficient goods. That's what it says. Okay, so what does that mean? I'll explain it to you in layman terms. Efficient goods. And I apologize if you can't see that below, okay? But why does economies of scale take place? Why does this happen, right? So everyone notices what happens in this graph here. On this side, this is my long run average cost, right? As I'm producing, right? I'm this pizza guy. I just start off with 0 output, right? 0, right? In the year 1. And as I produce, right? As I'm trying to grow, I have this downward facing cost curve, right? So what does that mean? It says that as I produce more quantity, right? As I produce more quantity in this region, right? As I produce more, my costs are decreasing. What happens when costs decrease, right? So remember, profit, right, is total revenue minus total cost. If your cost is going down, right, your profits are going up. So that's why all the producers want to expand, because they want to face this downward sloping cost curve. Economies of scale in economics is a huge concept because all people want to take advantage of it, right? Basically states that if you expand, there are advantages for you as a producer, right? Because of 2 things. Specialization. Remember what happens when I go from that first worker to 5 workers, right? People are starting to specialize in their tasks, right? The reason why Model T was such a successful car is because Henry Ford understood the concept of specialization, right? Each person would do a particular part of the production process for a car, and that's why the Model T was so successful, right? The point is that with specialization in the second part of economies of scale, purchasing efficient good, it basically states that as you become bigger and bigger, right? Imagine a company like Walmart, right? Walmart is a huge retailer in the United States and abroad. They have international presence as well. So if you take Walmart, right, which is a they're a $200 billion company, right? They're one of the largest retailers. They have the ability to play with volumes, right? So they can go up to someone and ask the cheapest price for their own to sell it because they have the ability to control the market, okay? So what this basically says is as you become bigger and bigger, right, you have the ability to become 1, smarter at buying your goods, right? Buying those goods, and 2, you have the ability to make sure those costs are getting down, right? Now imagine I take a small restaurant, right, and it becomes Pizza Hut, right? So Pizza Hut is this huge retailer. They have now this huge restaurant chain, right? They've perfected the process, right? They know exactly how to make these goods, right, in the most efficient way, right? And this is exactly what they talk about, right? As you expand, you've made enough mistakes, and you put in enough capital, right, in the long run to figure out how to make things in mass production. Henry Ford figured that out with a car, right? My example, I turned my small restaurant into Pizza Hut, and what I do is in that process, in that journey, right, of growing my company, I probably figured out more ways to buy, superior technology to make sure my things are cheaper, right? Make sure that I've perfected my processes so that they're cheaper and more efficient to build my goods, right? So this basically economies of scale says in this part, right, as I grow, my costs start to decrease, right? And that's why as a producer should always be thinking about how can I expand my business to make costs cheaper and my profits higher. And economies of scale is this concept that explains it. That being said, we're going to talk about constant returns of scale and diseconomies of scale in the next lesson. But I really want you guys to understand economies of scale because it's a really important part in economics. And I promise you it'll show up later on if you choose to pursue economics as a study, which I recommend to all of you. But that being said, this is what we have for today. So summarizing what we went on, we kind of went over some short-run cost concepts, right? We kind of graphed average product, marginal product. We graphed marginal cost and average variable cost, right? And we discussed the long-run average costs. And we start off with economies of scale, and we'll talk about constant returns of scale and diseconomies of scale. That being said, what is my homework question for you guys? I really want you guys to draw this graph, right? So, I really don't care, if it's going to be a simple process. The reason why this is important is to understand that LRAC, right, is a combination of a lot of SRACs, right? It's just a combination of short run average cost together, right? So draw me this exact graph, okay? Draw me the LRAC, split it into 3 parts. Show me the economies of scale, constant returns of scale, and diseconomies of scale. The next lesson, I'll come back and I'll explain to you guys constant returns of scale and diseconomies of scale. And we can cover up long run costs and then move on to more exciting stuff like perfect competition. All right, so that being said, hope to see you guys in the next lesson. Thank you so much for joining me. Hope to see you guys soon.